4 examples of factoring completely. Originally, I was going to do these problems at the end of the video last time, but I looked at the clock and I was like, okay, it's getting a little bit long. You probably need a breather. So let's do 4x squared plus 80x plus 400, but let's factor completely. Well, first things first, can I take something from all 3 of these terms? Yes. I'm going to divide all 3 of these terms by 4. So I'm going to factor out the GCF, which is 4. Okay? 4 times what is 4x squared? X squared. And then 4 times what is 80x? Positive 20x. And then 4 times what is 400? Positive 100. So now I ask the question, is this factored completely? No, we can break down this quadratic trinomial into 2 binomials. So let's look at the case that we have. Let's pay attention to the C, let's pay attention to the B. Well, the C is positive 100, and the B is positive 20. So we're looking for 2 numbers that multiply to positive 100 and add to positive 20. So we look at our 4 cases that we know so far, and we examine what do the numbers need to be. Well, if it multiplies to make a positive number, then the combination needs to be either positive positive or negative negative. So positive positive or negative negative, it has to be positive times positive, because positive times positive is a positive, and 2 positives added together make more positives. So let's make that table. 1 times 100. 1 times 100 is 100, but 1 plus 100 is 101 Dalmatians. Okay, so let's do 2. 2 times 50 is 100, but 2 plus 50 is 52. 100 divided by 3 is going to be a decimal, so we forget about it. 100 divided by 4 is 25. 4 quarters make $1. 4 times 25 is 100. 4 plus 25 is 29. 100 divided by 5, that's 20. 5 $20 bills make $100. 5 times 20 is 100. 5 plus 20 is 25. Look how much closer and closer we're getting to 20. I can't divide by 6, because I can't divide by 3. Can't divide by 7. Can't divide by 8. I can't divide by 9, but I can divide by 10. 10 times 10 is 100. 10 plus 10 is 20. We've got a winner here. So the winning combination is positive 10, positive 10. So now I look at this factored out 4. And now that the winning team is positive 10, positive 10, this factors into x plus 10 times x plus 10. I am totally okay with this layout. However, if you want to be fancy, if you want to be a fancy California student, you can write it like this. X plus 10 quantity squared with the 4 factored out. But personally, I even though California wants it like this, I like it expanded, x plus 10 times x plus 10, because it helps you in the long run for Algebra 2, Pre-Calc, and Calc, in my opinion. So either way works. I'm not picky, but I do want to see that the 4 is factored out, and you acknowledge that the winning combination is x plus 10 in some form. Okay, let's take a look at problem number 2. 2x squared minus 28x plus 98. Can I factor something from all 3 of these terms? Yes, I'm going to factor out the 2. 2 times what is 2x squared? 2 times x squared is 2x squared. Negative 28 divided by 2. So 2 times what is negative 28x? Negative 14x. 2 times what is positive 98? 98 divided by 2 is positive 49. Is this factored completely? No, I can break down this quadratic trinomial by figuring out what multiplies to c and adds to b. So let's look at this table. The c is positive 49, and the b is negative 14. So I'm looking for two numbers that multiply to c equals positive 49 and add to b equals negative 14. So I'm going to cover up the right column and look. How do I get to multiply positive 49? Well, the two numbers need to be either positive positive or negative negative. Two positives add together to make positive, and two negatives make more negative, so the winning combination needs to be some sort of negative negative. Let's start with negative 1 and negative 49. Negative 1 times negative 49 is positive 49, but negative 1 plus negative 49 is negative 50. That's not what I want. Well, I run through the list of terms. 49 divided by 2 is a decimal. 49 divided by 3 is a decimal. 49 divided by 4 is a decimal. 49 divided by 5 is a decimal. 49 divided by 6 is a decimal. But 49 divided by 7 does get me a whole number. Remember, it has to be a negative negative combination. So I'm going to do negative 7 times negative 7. Negative 7 times negative 7 is positive 49, but two negatives, negative 7 plus negative 7, makes negative 14. We win. So that is our winning team. So remember, we looked, did I factor something out in advance? Yeah, this 2 is factored out. And we're going to factor this quadratic trinomial by breaking it into x minus 7 and x minus 7. Okay. Let's take a look at number 3. Can I factor something out of all three of these terms? 7x squared, positive 63x, and negative 630. Can I factor something from all three of those terms? Yes. So I factor out the 7, and I'm going to take out the 7. 7 times what is 7x squared? X squared. 7 times what is positive 63x? So what's 63x divided by 7? Positive 9x. Positive 7 times what is negative 630? Well, that's going to be negative 90. Oh, boy. Well, is this factored completely? No. So I'm going to factor out that quadratic trinomial by figuring out what two numbers multiply to negative 90 and add to positive 9. Remember, the sign goes with the number. So I'm going to cover up the right column and look. How do I get two numbers that multiply to get to negative 90? Well, it has to be some sort of positive-negative combination, so one of each. But what does adding to positive 9 tell me if the combination needs to be some sort of positive-negative? Well, the positive number has to be stronger than the negative number. So we're going to make a list of weak negatives and strong positives. Let's get right to it. Let's try the first one, negative 1 and positive 90. Negative 1, positive 90, they multiply to make negative 90, but they add together to form positive 89. Let's try negative 2 and positive 45. They multiply to form negative 90, but they add to form positive 43. Let's try negative 3 and positive 30. Negative 3 times 30 is negative 90. But negative 3 plus 30 is going to be positive 27. 90 divided by 4 is a decimal, because I know 4 goes into 88 and 92. So it'll be 22.5, I believe, so it's a decimal, so forget about it. 90 divided by 5, I don't know that off the top of my head. I think it's 18, but 90 divided by 5, I get a calculator, it's 18. So we're going to try -5 and positive 18. They multiply to -90, but they add to positive 13. Well, if it's divisible by 2 and 3, it has to be divisible by 6. That's just college number theory. 90 divided by 6 is 15. So let's try -6 and positive 15. -6 times 15 is -90. -6 plus 15 is positive 9. There's our winning team. So I guarantee maybe a few of you didn't know this combination off the top of your head. Make that table, okay? If you look at this problem for more than 3 seconds and you don't know the winning team, make that table, because otherwise Algebra 2 is going to be really, really tough. So now that we know that the winning team is -6, positive 15, we factor out the 7 in front, and we make the two binomials as such. The winning team was -6, positive 15, so that's x minus 6, x plus 15, we have a winner. Okay? See if you guys can do number 4 on your own. 2x squared minus 42x plus, minus 144. So let me rephrase that. 2x squared minus 42x minus 144. Make that table. Well, first things first. Can I divide something from all 3 terms? Yeah, I'm going to factor out the 2. So now I'm going to divide everything on the everything in the polynomial by 2 by factoring it out. 2 times what is 2x squared? X squared. 2 times what is -42x? -21x. And 2 times what is -144? Well, that'll be -72. Okay? Is this factored completely? No. So I'm going to look at what multiplies to C and what adds to B. Two numbers that multiply to -72 but add together to form -21. So I always look at the multiplication part first. If it multiplies to make a negative number, then the combination needs to be positive times negative. So one of each, one positive, one negative. So what does adding to -21 tell me about the positive-negative combination? The negative needs to be stronger than the positive. So it's going to be a big negative and a small positive. So let's get right to that. 1 times -72. 1 times -72 is -72, but 1 plus -72 is -71. Well, that didn't work, but luckily we're going to try until we get that winning team. So let's try 2 times -36. 2 times -36 is -72, but 2 plus -36 is -34. Can I divide by 3? Well, I don't know what that is in my head. 72 divided by 3 is 24. So let's try 3 and -24. 3 times -24 is -72. 3 plus -24 is -21. So, check. So the winning combination is +3, -24. So let's put that into our factored form. I'm going to factor out the 2. Okay, so the winning team again was +3, -24. So this factors into x plus 3, x minus 24. Okay, so I just want to give you guys a sneak preview of what we're going to be doing after spring break. So please take notes on this part. Oops, over here. I don't want that. Where's the notebook? There it is. So what's different about problem number 5, x squared minus 9? There doesn't seem to be just an x, so that middle term is gone. I've got an x squared, I've got a constant is a number without a variable next to it, but I don't have a middle term. Maybe if I rewrite the problem as x squared plus 0x minus 9, that'll clear everything up. So this does help, because now I see that the c is negative 9. So what two numbers multiply to negative 9 and add to 0? So I'm going to cover up the right column again. If it multiplies to negative 9, what does the combination need to be? Positive, positive, negative times negative, or one positive, one negative? Well, it has to be some sort of combination of positive times negative. So, but if it adds to 0, that really confuses me. Well, it couldn't hurt to just try. Positive 1 times negative 9. 1 times negative 9 is negative 9. 1 plus negative 9 is negative 8. Okay, let me try dividing by 2. 9 divided by 2 is a decimal. So that'd be 4.5. I don't count it. Can I do 9 divided by 3? Yes, in particular, negative 9 divided by positive 3 becomes negative 3. So 3 times negative 3 is negative 9. 3 plus negative 3, there we go. We've got our winning team. The winning team is positive 3, negative 3. So therefore, if I look at x squared minus 9, I could rewrite this as x squared plus 0x minus 9. And that becomes the winning team of x plus 3 times x minus 3. Do you guys notice a relationship between 9 and 3? Well, let's find out. All right, x squared minus 4, same thing. I've got x squared minus 4. I don't seem to have a bx. There's no middle term. So what can I rewrite this problem as? Let's say I make the middle term 0x. That's totally fine. So now that I know that my c is negative 4, so what two numbers multiply to negative 4, but add to 0? So I'm going to cover up the right column. How do I get two numbers to multiply to negative 4? Well, it has to be some sort of positive-negative combination, a positive times a negative. But it adds to 0, so I can't really tell which one's stronger, the positive or the negative. So let's try 1 times negative 4. 1 times negative 4 is negative 4. 1 plus negative 4 is negative 3. Okay, can I divide by 2? Yeah, 4 divided by 2 gives me a number. So in particular, negative 4 divided by positive 2 is negative 2. 2 times negative 2 is negative 4. 2 plus negative 2 is, oh, we win. Oh, this is beautiful. We have a winning team, positive 2, negative 2. So if we have x squared minus 4, that can factor into the winning team of x plus 2, x minus 2. Okay. Do you guys notice something? So I'm going to refer back to this. The relationship between 9 and 3, 4 and 2. Let's see if you have an idea about x squared minus 25 without actually doing this. But I'm going to do this anyway. Let's see if your theory is correct. Once again, I don't have a middle term bx, so I'm going to make this x squared plus 0x minus 25. So I'm figuring out two numbers that multiply to negative 25 and add to 0. Once again, two numbers that multiply to make negative 25 need to be some sort of positive times negative. But that adding to 0 thing, it's still confusing to me. So let me just list out some suspects with positives and negatives and hope I get somewhere. Let's try 1 times negative 25. 1 times negative 25 is negative 25. 1 plus negative 25 is negative 24. Can I divide by 2? No. Decimal. Divide by 3? No. Decimal. Divide 25 divided by 4? No. Decimal. But I can divide by 5. 5 times negative 5 is negative 25. 5 plus negative 5 is 0. We have a winner. So that becomes x plus 5, x minus 5. Okay. Let's try x squared minus 36. Do you guys see a relationship between 25 and 5? Let's see if your theory is correct for number 8. X squared minus 36. Oh, oops. I don't want to give away the answer. Oh, now I remember what I was going to do. X squared plus 0x minus 36. Well, remember, we're trying to figure out what two numbers multiply to negative 36 and add to 0. Okay? So, it needs to be some sort of positive-negative combination, but they add to 0. I think I have an idea of what that combination is going to be. Let's try 1 and negative 36. They add to negative 35. Divide by 2, yeah, it's an even number, so it has to have a whole number when I cut it in half. 2 times negative 18. 2 times negative 18 is negative 36, but they add together to form negative 16. Divide by 3. Negative 36 divided by 3 is negative 12. 3 times negative 12 is negative 36. 3 plus negative 12 is negative 9. Let me try 4. 4 times negative 9 is negative 36, but they add to make negative 5. I'm getting frustrated. 36 divided by 5 is going to be a decimal, but let me try 6. Negative 36 divided by 6 is negative 6. So 6 times negative 6 is negative 36. But 6 plus negative 6 adds to 0. This is our winning team. So the winning team, to factor x squared minus 36, becomes x plus 6, x minus 6. So some of you guys are really antsy because you guys know this in your head already. The relationship between 9 and 3 is that 3 squared is equal to 9. The square root of 9 is 3. The relationship between 4 and 2, 2 squared is 4. The square root of 4 is 2. The relationship between 25 and 5, 5 squared is 25, and the square root of 25 is 5. The relationship between 36 and 6, 6 squared is 36, and the square root of 36 is 6. That seems to be the recurring theme in all 4 of these problems, and you're 100% correct. So if I take a look at this, this is the last case. There were 4 cases that I gave you, where multiply to positive, add to positive, multiply to positive, add to negative, multiply to negative, add to positive, and multiply to negative, add to negative. This is the 5th case. So if you have something like a squared minus b squared, right? This is a square minus a square. And in proper math vocabulary, the answer to a subtraction problem is called the difference. You guys remember those elementary school worksheets where you guys had find the difference and find the sum. It means add the 2 numbers together. Find the difference means solve the subtraction problem. So what this is called is, I want you to take notes on this. This is called the difference of 2 squares. So the difference of 2 squares means that we have a subtraction problem involving 2 numbers being squared. And we can break this down into the formula a plus b times a minus b. So the difference of 2 squares, go back to the FOIL unit, and a plus b times a minus b forms a pair of conjugates. Straighten that tie. Straighten that tie and say conjugates. So if you have a subtraction problem involving two squares, you break this down into a pair of conjugates. So you have, let's just say we go to the last problem, x squared minus 36. Well, the square root of x squared is x. The square root of 36 is 6. So you make them into conjugates, x plus 6, x minus 6. And just to show you that the general formula works, what happens when I multiply a plus b times a minus b? Well, I FOIL this. A times a is a squared. A times negative b is negative ab. Positive b times positive a is, you could say ba, but I like to say positive ab. And finally, positive b times negative b is negative b squared. So if I FOIL this out, or you did the rectangle, you'll notice that the negative ab and the positive ab will cancel each other out, leaving me with a squared minus b squared every single time. And just to show you that x squared minus 36 is equal to x plus 6 times x minus 6, if we FOIL this out, I'm left with x times x is x squared. X times negative 6 is negative 6x. Positive 6 times positive x is positive 6x. And positive 6 times negative 6 is equal to negative 36. Can I combine like terms? Yeah, I'm going to combine the like terms in the middle. Negative 6x and positive 6x knock each other out, getting me x squared minus 36. So when we get back from spring break, we're going to be doing factoring in all 5 formats. Okay, and I'll make a little cheat sheet for you guys. If you have already the 4 cases, add the 5th case, which is the difference of 2 squares makes conjugates. A squared minus b squared is equal to a plus b, a minus b. Have a great day.